Hi folks, I'm making this video here to talk about the two homework problems that we were chatting about in class today. So first let's talk about 795. And I've determined pretty well exactly why you're having trouble getting your work to match the back of the book. I looked up the solution manual. It turns out it's just wrong. And I'll explain it and I'll bring it to class on Monday. But I mean, here's the deal. I'm looking at their solution right now. They have a free body that looks just like the free body that I've been recommending that we start with. They start with a moment equation about A, and what they have when they do some moments about point A is minus tension dB cosine 59 degrees. For the x component of this, then they have times 2 meters plus tension dB sine 59 times I'm sorry, feet though, not meters. Then they have times 10. Then they have minus 50 times 7 minus p times 3 equals 0. So their moment equation here is kind of screwed up, and let me talk about why. They're summing moments about point A. I'm going to put a red dot on A. They did in this solution counterclockwise positive. So the p times 3 is fine. This one right here, including the sign, no problem at all. This one right here, the 50 times 7 is for this force, and it's fine. The tension dB sine 59 times 10, so that's going to be the y component of this force. Boy, I hadn't even checked that, but I think they got that wrong too. It is the 10 feet. The moment arm for the y component of this force should be this distance, and I'm looking at that picture right now, and it should be 7 feet right there. I was talking about this term as the one I believe they have a problem with. The tension dB cosine 59 is the x component of this. Now for starters, backtrack that, that's producing counterclockwise moment, so that should be a plus. And then the moment arm for this force right here, backtracking it, is this distance, and I'm looking right at the picture right now. I believe that should be a 3. So that equation to me looks like it's got like 3 problems with it. So if your answers are not working out at this point, I wouldn't worry about it. I'm just going to let's just abandon that solution manual, and we're going to all work this out until we all get the same answer. And here's what you do. Again, I've talked about this in class. We've got 1, 2, 3, 4 unknown forces. You should be able to set any one of them to some value and figure out what the others are. I'm going to start this. I'm going to suggest we start this the way they started it. Set that guy right there to 75. Then calculate this guy and this guy. If both those values are less than 75, you're good. Then calculate P. If you set this to 75 and one of these two come out bigger than 75, that means that one of these will break first. So let's say that AC comes out to be bigger than 75. Then set AC to 75 and work the rest of the problem out. You can actually, if you set this to 75, you should be able to do just a free body of this to nail down both of these. And again, let's not worry about what the manual says, because I'll show you on Monday, but I found 3 mistakes in one equation there. So I wouldn't even worry about what that thing said. So we talked about in class about how, well, maybe we're making a mistake and I didn't think so, or maybe there was an algebra problem, or third possibility was the manual, and in this case, that's what I believe. I believe that that moment equation they used to solve this is just fraught with problems. But all right, let's talk about 27. So we talked about that in class, and the idea was to find P min such that this thing stayed static. And the free body we had in class looked just like this. It's got that force P at some sort of angle. It's got a frictional force, a normal at an unknown location. And I stand by that. That's an unknown distance between the normal and the mg. Now, if we consider sliding friction first before tipping, then we've got P cosine theta minus F equals 0. So I'm going to call that equation 1. Some forces in the y direction is going to be this equation, n minus mg plus P sine theta equals 0. And if we're considering sliding for pending motion, then we can say the frictional force is equal to the coefficient of friction times the normal. So where we got hung up in class was we were actually overthinking it. The location of this normal is not important for the sliding, so we don't really need to worry about that. And it doesn't show up in these equations. If you look at these equations carefully, the friction, the unknowns here are like the normal and P. And what we can do here is combine these equations, and I think I actually did a line here. So for example, if we say the frictional force is the coefficient of friction times the normal, we can put this value here. And the normal you can get from this equation. It's equal to mg minus p sine theta. So the new equation, I wrote it out here. Here's our p cosine theta minus coefficient of friction times the normal equals 0. Now, like I mentioned in class, the mystery here is the part about we have to figure out how to incorporate the find the minimum value of P. And P is changing against theta. So what you want to do with this is solve this equation for P, so you'll have P equals a bunch of stuff here, and this stuff on the right will have thetas in it. And because we're trying to minimize P, calculate dP d theta and set it equal to 0. When you do that, you're going to be optimizing P. Now, whenever you optimize, you should always check to make sure the value you get, whether it's a min or a max. After you get the value of P here and theta, that minimizes P, you should check that against d squared P d theta squared. And if this value is greater than 0, that means that the P is a relative minimum. If this value were less than 0, that means that the values we found were a relative maximum. So this is the part that, and I apologize for just not seeing that or thinking about that in class right here, but the part is the minimization part. So solve this for P, and this is what we do to minimize P. So that should be enough to get both those done. Here we don't have a solution manual to work with, so we're just going to work this out until everybody has the same answer and call that good. So I hope these videos get you through both problems. Have a great day.